Our next conversation is with David from FPC Global, and it's a real eye-opener about the complexities of implementing new technologies in this industry. David's perspective is particularly fascinating because he sheds some light on something we don't often consider, and that is the misaligned incentives that can really hinder technological advancement in the commercial real estate sector.
The person who owns the building isn't the person who operates in the building, who is the person who leases the building and uses it. Those are different actors, right?
This fragmentation of roles and responsibilities creates a complex web of interests that don't always align when it comes to implementing new technologies. And what's more, David highlights a critical challenge that many in the industry face: the lack of data. You can't leverage AI without good data, and in many cases, that data simply isn't being collected or isn't accessible. But what really caught my attention was David's insight into the industry's historical approach to technology.
And we're seeing that. And so there's relatively new for the industry, language that we use, BACnet, Modbus, these kind of, and some are more popular in certain regions of the world. The inevitable goal is to get to IP addressed APIs.
I was genuinely shocked to hear that APIs, a technology that's been standard in my industry for decades, is still considered new in the commercial real estate sector. The fact that this transition is still ongoing in 2024 speaks volumes about the unique challenges the commercial real estate industry faces in modernizing its technological infrastructure. I'm here with David Stoller from FPC Global, and we're going to be talking about a little bit of AI in building operations. So tell us a little bit about what you do.
So we're an organization that focuses specifically around the kind of the gap in the market between underneath the software and above the hardware in the operative world. So anywhere operative technology, things that are physically driving, changing, making the world work, whether it's a motor, a lighting, electrical, building automation, industrial automation, manufacturing automation, and software intercede. We specialize in kind of making that connection, deploying it at scale, and then ensuring it's done securely and works right.
Yeah. So being able to take what happens in digital world, but bringing it to the physical world through that.
Taking what's happening in the physical world and replicating it in the digital world and providing insights, and then inversely driving changes down into the physical world. So capturing what's happening with every traffic light in the city and understanding what's happening there and how that affects traffic patterns, and then being able to remotely make dynamic changes, right? So that's an example where we're taking physical world infrastructure, operative technology, connecting it to the internet, right? Creating internet technologies where internet's really, software is great at analyzing, providing insights, but then driving that back down. There's a gap in the market where people don't know how to connect those things. The operative world is very complex and a lot of legacy, proprietary protocol and communication systems. And the software world is really new and fresh and well-designed and purpose-built. And so connecting those two things can be a challenge. So that's what we specialize is.
I recently just had that on my way to the airport coming to this conference. I was like, why are the traffic lights not more well-timed? What are some of those challenges? I mean, like you said, everything in the software world is kind of purpose-built. We're now talking about legacy systems. What has been that kind of challenge over the last 30 years, becoming technological, getting into the technological and software realm?
Certainly, yes. So I think, one of the biggest challenges is the physical world's been with us for a very long time, and the technology stack around us dates back a lot longer than the internet, ostensibly. And so for the longest time, the way organizations created strategic advantages was by creating walled cities around their technology. And so they would use proprietary systems, proprietary protocols, and this would insulate them from losing their client to a competitor in some capacity, right? And the reality is, for the most part, these organizations make hardware and they sell hardware, but their real goal is to sell service agreements, maintaining and managing and ensuring that those things operate properly. And so the way that you're able to do that is not allowing anyone else to be able to service it, because legally they're not allowed to touch your communication protocol. And so for the last 30 years, that's slowly been eroding. I think clients are making demands to be more open, and we're seeing that. And so there's relatively new for the industry, language that we use, BACnet, Modbus, these kind of, and some are more popular in certain regions of the world. The inevitable goal is to get to IP addressed APIs, but it can be a challenge. And some of these organizations that are responsible for it, they're industrial giants. I know we tend to think of big tech as, Facebook, Azure, Microsoft, whatever. But big tech, industrial tech is industrial guys like Schneider, Schindler. So the people that are building these massive industrial automation factories or these giant wind turbines that are powering green energy, they're these legacy companies that have been using these Stoller protocols forever. And so it's hard to shift and change them over time. Right? So,
And I can imagine too, now that we have AI in the mix, everyone's like AI, AI, AI. It's not like AI has been new, but now generative AI. And when an AI makes a mistake and it writes a bad blog post, no one dies. However, in the real world, if something happens, there's a real life consequences. So you have to naturally be slower to adopt. How have you seen that adoption, and how long has this space been using other forms of AI and machine learning to help with that?
so we've been doing it for a long time, honestly. A linear regression model is technically AI as machine learning, right? So in that sense, yeah, I would not consider it a true AI in the modern sense. But we've been using linear regression model to make predictions and analyze what needs to happen or when things might fail, whatever, right? For a long time, for decades at this point. The real kind of more shiny parts of AI, the challenges that we're seeing it's functionally that connectivity, right? There's a lot of risk associated with connecting the physical world because of malicious actors. It's one thing when someone gets in and gets your email and they find out that you've been subscribed to some awful newsletter that you're embarrassed about. It's a lot different when someone into Hoover Dam and shuts off the generators and all of Nevada loses power, right? And so there's a lot more risk associated with the physical world. It actually, I kind of a dick about it, but like it actually impacts our lives. Like the operative technology world is how we interact with the world. The way we get our water, it's the way we make all of our goods. It's the way that we get our electricity. It's the way that we cool our buildings. It's the way we keep our food safe, right? In refrigeration. And so
how we power computers to even make the software?
Right? So, people are understandably like nervous about connecting to the net. And so that's the first step. And so you can't run AI on it unless you're connected. But I always argue, and people say, well, we don't want to connect because we don't want to. Well, if you're not connected, you don't actually know if someone else is doing it. And that's the challenge is, these are not monoliths, these organizations. The person who owns the building isn't the person who operates in the building, who is the person who leases the building and uses it. Those are different actors, right? And so they all have different goals, different incentives. And so if I'm trying to protect my asset and not connect to it, or whatever the case may be, whatever operative technology, that doesn't mean that the person who's managing and maintaining it in the local office isn't doing it because he makes his life easier, right? So without actually having connectivity, you don't know if someone else is. So if you think about some of the largest hacks that have happened in the last decade, right? Target, MGM, those were all originated in operative technology systems that were connected to the network, right? Without approval, right? So I think MGM was like a salinity monitor in a fish tank that some local tech had put in because it made his life easier. Target was it was actually an executive's Nest thermostat in his house. And he was getting onto the network remotely. And so they went in because it was an unsecure device. And so I think the importance of connecting and monitoring operative technology is incredibly important. It is a little risky, but we have to do it because because of the way it's happening organically is dangerous. And so from an AI perspective, that's the first step. So the next challenge, I think the reason that's been a challenge though, is the way that the built world comes to exist. And there are several different stakeholders involved and they all have different incentives, right? So you have a real estate developer, person who builds these buildings. They're functionally speculators, right? They're like, I think if I do this, it'll get this and I'll be able to generate this return, right? It's a speculative investment. They want to build it for as cheap as possible. And the way you do that is you scale back capabilities inside of the actual building process, right? So if I'm going to build this building, I can build a dumb building, I can build a smart building, I can build a state-of-the-art. If I build a dumb building, it's cheaper, right? And so that's what happens in a lot of cases.
Cheaper to build, more expensive to maintain, though?
Absolutely. But that's not what they're responsible for. They sell the building, and then you build into what's called the asset manager, the ownership group. They're responsible for maintaining that. So most developers build and then sell. They build the core and shell, they get it ready, and they sell it to somebody else. And then there's these organizations called like REITs or even family offices. They buy the asset, have a tenant in it, and they use it as a cash flow. They use cash flow from these rentals to kind of structure it as a bond, a REIT, a real estate investment trust. So these people own these assets. Oftentimes they may just own it on paper, and then they lease out to what's called a service provider, someone like Cushman & Wakefield Jones Lang LaSalle. They operate and maintain the building. So they're often 3 people removed from the actual building of that building. Got it. Right? And so to have done it right, make it ready, the decision was back here, and the person who deals with the consequences is here. And that's why oftentimes you have people connecting on their own because it makes their life easier, but now that whole system is at risk because they connected it in an unsecured way.
Yeah. So sounds like a lot of misaligned incentives.
That's exactly what it is. And that's just the nature of the physical world. I mean, we've had this massive innovation spike in human history, right? In the last 15, 20 years. We've been building buildings centuries.
Yeah.
And so
almost the long civilization.
Yeah, right? Like it's kind of what defines civilization. Yeah. And so, the way that we build them and the order in which people are responsible for things is often due to, we do structure first because you need a structure. Then you start doing, roofing because we better have roofing. And then you do plumbing because, now we've invented plumbing. So plumbing's now in charge, And so the order at which we do things and add into our process is often not necessarily the right decision, right? Oftentimes when we build it, the last thing that goes in is the software guy, the tech guys, the network guys. They come in at the end, everything's already been done. Some of this stuff is not accessible, it's behind walls, but that's because they were the last to be invented. Yeah. So what we really need to do is people are always like, oh, do we have the right thing? We have enough tech. We can send people to the moon. We have everything we need to achieve the goals that we want from our assets today. We just do. What we lack is people and processes, organizational readiness to be able to understand how you can use AI, and processes to ensure that it gets deployed in the way that you want it for the goal that you're trying to achieve.
When you're building a building, when you're making the plans, you're doing it not even based off the technology that's out right now. You're doing it off probably even 5-year technology that's well and solidified, if that. And therefore, by the time the building gets built, the technology or anything that was in there is probably planned for. I mean, is that an accurate assumption?
I wish it was. The reality of these misaligned incentives, so we can get into the real nitty gritty if you like. So you have a developer, they're the money. They're the guys, they raise the money, they're speculating. They hire an architect, part of the design. The architect's job, oftentimes they're very aesthetically driven, experientially driven. They tend to look at the actual technology goes as the responsibility of the engineer. And so the way everyone here makes money is the developer, they build for a certain dollar and they sell it for more. That's just straight up what they do, right? That's how they make
They're mainly just finance, buying a stock.
Yes, exactly, right? They're making an investment, they're turning around and returning theirs. The architect has a service fee, they're retained, right? So they get job, they know they're going to work on it. The engineer has documents they need to deliver. So they're going to go, oh, it's this big, this many systems. I need 100 hours, whatever, we'll say 10 just for a second. And the way they make more money, they work less hours. And the way that they can do that is they can outsource the actual design of a lot of these subsystems to either the people who built them, which they do for free. So if you say, hey, I need a mechanical system, and you call the big mechanical company Train, they will design your mechanical equipment. They'll size it for you. And guess what they'll also do? Make sure it's all Train equipment. When you need controls and you ask Siemens to do it, they're going to make sure it's all Siemens. It's just the way the business has worked. Or if they don't want to do that, if they want to be really cost effective, they'll go find a plan from 5 years ago that they already did that's a similar footprint and just copy it. And so they'll make a few changes. And so you're oftentimes having specifications for systems that are decades old. Some of them don't exist anymore. And when you do that, you end up kind of what I call like the MVP, the minimum viable product to deliver what needs to be done.
So I hear a lot of proprietary and do-it-ourselves kind of like in the ethos here. Now, when it comes to LLMs, AI, is that kind of same ethos? Like, oh, we just got to do it ourselves. We have to keep it in our own area. Because none of these companies are really, maybe like a Siemens, it's like, huge. They may have the resources, but what are you kind of seeing in the industry?
So I think a lot of people like to think that they're going to do it themselves, and God bless them. I personally think there's a point where you just need to accept that you're good at what you're good at and not good at what you're not good at. And that doesn't mean that there aren't smart people at all these organizations. But the ability to develop ground up large language model versions of AI when your job has been turning wrenches and rolling trucks for the last 50 years is kind of absurd, right? Like, I don't ask my plumber, the plumber in my house doesn't come in and be like, hey, have you considered my large language model? No, right? Not to be dismissive, right? There's a lot of really brilliant people. I love these organizations. They're my friends, I work with them. I used to work for them, but it's just not necessary. These are large organizations that make money a very specific way. And the way they make money is putting equipment in the building and then rolling trucks to go service it. And so all of a sudden they're going to build a large language model to mitigate that. There's a lot of political challenges that come along with that.
Because it could reduce their service business.
If it reduces your, well, it could make it more profitable, sure, but it means I have to lay off people. And a person, maybe the person whose job it is to make that decision, their power is dictated in many ways by how many people they have, right? I control a team of 10,000 people and this many assets. That's how I retain my prestige. I'm the service manager. And if you were to undermine that and turn it into a small group, politically, does that person want to make that happen? Are they incentivized? Like, yes, from a financial perspective, but from a prestige perspective, I don't know if they are. So I think there's a lot of political stuff, and we need to look into the human psychology of what drives these changes and adoption a little bit more scrutiny.
So I'll end it on this last one. When I think of AIs taking over buildings, my mind goes to 2001 Space Odyssey. Like, sorry, Hal, I can't do this. Me even being an AI, I'm like, I still get a little kind of nervous. Yeah. I don't know why about that, but being someone who's in the industry, why is or isn't that not going to happen?
So there is a product, there's some stuff already out there, right? I know guys over at Brainbox have a building AI that'll do that. It'll tell you what's going on with your equipment. The challenge, though, is still it only knows what it's connected to, right? The AI isn't going to walk in and magically learn. If you walk around your house, you walk around your office, how much of that is actually IP addressable today? Mm-hmm. And the cost of doing it is pretty challenging. And the value proposition hasn't been fully ironed out. And so I don't think we're there yet. I think the first step, and I know this is AI and we love talking about AI, but I'm personally sick of this industry talking about AI when they don't have connectivity strategies, data ontology strategies, data aggregation and analysis strategy. It's like that meme of the kid stepping 3 steps over, and we need to just build a process to do the first things. And the reality I know enough about AI that it's data hungry. Well, we don't even have data. We're not going to be able to train these systems. If we started connecting every single thing today in every single one of these buildings, and it took us 5 to 10 years, and then we had an AI at the same time at the end of those 10 years, it would be trained out in a week, right? It wouldn't even be ready because it needs so much more data. So I think we're just light years. We can do some things, but to have that real future end states building that's dynamically adjusting, we just need to collect more data. Yeah, and that's just the reality.
I think that a lot of industries, a lot of people, a lot of companies weren't great at data management even before AI. Now you have this thing that's both can collect the data, but also can generate data on unprecedented scales. And I think all industries.
And that's another thing. It's when we're dealing with the physical world, is synthetic data a good choice? Is that okay? It's one thing if, we're trying to teach it on how to write, interpret words or books, that's one thing, and it's going to spit back a blog post for you. But if it's being trained on synthetic data that inadvertently causes the refinery to explode, that's.
I think there's a middle ground too between synthetic data and then real data, is because I think a lot of companies have unstructured data, and then using the AI to create the structured data that then powers their prediction models and things like that, so where it is semi-synthetic, but it's based off of their own, and then still meticulously looked at with a fine-tooth comb. You have to validate it for sure.
I think the one thing I would just echo, anyone who's interested in doing if you're a CEO and you want to talk about AI, let's put a plan together to actually capture the data right now. Let's put the money where the mouth is. If this isn't just a talking point, if you fundamentally believe that this is of strategic importance to your organization and what you're going to do to be successful in the future, I personally think it is. But if you do as well, come on, let's put together a data aggregation strategy. Let's build it. Let's go. And a lot of people will say, "Oh, we get it." Do you? Yeah. Or is it an Excel file that some guy in a basement's filling out? Because I'm so sick of all these Excel files. The truth is, we're not capturing any of this stuff effectively today. So,
awesome. Well, thank you, David. I really appreciate it, and good luck.
Absolutely. Thank you.